Up next is Ben Dechrai from Auth0, and he's going to talk about authorized is not a yes or no question. Over to you, Ben.
Thank you very much. Thanks for having me. It feels very odd to be doing this at a live conference from my room. I'm very sad not to be there. The organizers and I were hoping that the bubble would be open by now, but no such luck. But I'm very happy to be here anyway, talking to you. There is also a camera watching you, so I can see you. So if you wave, then I can see you. And in fact, what I normally do hello, hang on, you're going to have to carry on doing that, because what I normally do is take a selfie with the audience, and this is going to be the weirdest audience selfie I've ever taken. So you can start waving again now. Oh, I better switch the camera around so I was actually looking at the screen. Alrighty, that's that out of the way. Thank you for your participation and your encouragement. All right, so yes, I want to talk to you today about, I'm also going to try and look to the camera because you are all beautiful people right there. So I'll be distracted and keep looking at you. Also, when I usually take that selfie photo, I will ask anybody in the audience if they want to obscure their faces for privacy purposes. I can guarantee you the quality of what I can see is not good enough to damage any of your privacy concerns that you might have. So we're all good. All right, moving on. Why I'm actually here rather than just to blather to you about selfies. I want to talk to you about authorized and authorization. Authorized is not a yes/no question. So we're all probably familiar, and the code samples in here are mostly JavaScript. This applies to every stack, every language that you might be working with. So don't worry if you don't necessarily understand the code. A lot of it is pseudocode, and hopefully the sentiment of what I'm trying to get across is enough. So we're all familiar probably with changing some kind of functionality in our applications based on whether or not a user is authenticated. Are they logged in or not? And adding this kind of functionality is relatively straightforward insofar as determining whether or not somebody is logged in can be as simple as, depending on your platform of choice, of just adding a login form. So this is an example from Laravel. A lot of PHP and non-PHP frameworks will have a really easy out-of-the-box mechanism for adding a login mechanism. And it'll stub out the database and make sure that the passwords are somewhat securely stored. And at the end of the day, your application will have a session with the user's web browser, and you'll know whether or not they're authenticated. And based on that, you can then make decisions on what you show, what you don't show, what functionality they can and can't do. Even easier than this would be adding something like a login with Google, login with Facebook, because then you don't even need to worry about the user credentials. All you know is whether or not you've got a token back from the identity provider they've chosen to use to log in, and you then know whether or not they're authenticated. You'll get a little bit of information back from that identity provider as well, so that you know in future whether or not the same person's logged in again. But again, we're still looking at basically is the user logged in, yes or no, which as a starting point is great. We, depending on the applications we're developing, we want to encourage people to join. We want to know whether or not they have an account. But there is a level of complexity that is not captured in pure authentication. For example, what if you wanted to determine whether or not a user has permission to do something like edit an item? We know that they're logged in at this point, but we don't know what the application or the API should allow that user to do without the extra bit of information. So just a quick bit about me. My name is Ben Dechrai, as you heard. I've been a software developer now for 21 years. This slide is from last year, and I don't know, I think it ticks over in June. So technically it's still 21 and a bit years. I do feel like an old man sometimes, just because of that number, not because of my... Anyway, I've really been passionate about security and privacy for probably most of that. Everything that I've done over the past 10 years, 15 years or so, has been with the lens of privacy, security, also civil liberties, all of those kind of things. I'm really passionate about making sure that developers, as developers, we keep our users and our customers secure and value their privacy. I've done a lot of work in open source and developer communities as well, running conferences, speaking at conferences like this. I really love engaging with communities and hearing what challenges we're facing as a developer community and what kind of solutions people are finding to that. And this culmination of software engineering, community engagement, security and privacy led to me being somewhat harassed, I have to say, by a developer advocate at Auth0, who was actually a friend of mine who kept telling me to apply to get a job there. I finally succumbed to the pressure, and I've been working at Auth0 now for 2.5 years or thereabouts. If you want to get in touch with me, we're going to have plenty of time after this talk for Q&A if you want to ask me questions then. But if you want to contact me at any time, my handle on pretty much most social media sites out there is Ben Dechrai. My Twitter DMs are open if you want to contact me that way as well. So let's leave that now and actually talk about what we came here to learn about, access control. So access control is basically the level on top of authentication where we know whether or not a user is allowed to perform a certain type of action. And there are two predominant ways that we define access control or define the rules that determine whether or not somebody or some system, it can apply between systems as well, whether they have access to do something. The most common one is actually role-based access control, the one on the right there. And there's also attribute-based access control, which is a bit of a mouthful, to be honest, and I'll probably get it wrong a couple of times during the session. ABAC and RBAC, much easier to say. RBAC is probably something that you've seen in some applications already. And we'll come to that in a second. We'll look at attribute-based access control first and see what that offers us and how it works. So the concept behind attributes is that there are four columns of attribute that can be top-level columns under which attributes fall, and they are used to determine access, usually a Boolean, like do they have access or not? You don't usually get a, well, it depends, sort of. They get half access. I don't think that's the thing. The first column is subject, and these are the things that are trying to access the object, which we'll come to in a second. So the subject is going to be the person or the system that wants access to perform a certain action on an object. And attributes for a person or a system could be department. Are they in the right organization within a company or a university? Do they have a certain level of clearance, whether that's government level clearance, secret, top secret, etc., or is it an internal organizational clearance level categorization or taxonomy that's been implemented? Some simpler things like age. Is the user allowed to buy alcohol? If you're running some kind of access control on an online shopping system where there are some things that people can buy and can't buy depending on their age. I don't know, it's a bit of an obscure example, but age could be a valid attribute of a subject trying to get access to do some action. And then what kind of action is it? We're probably all familiar with CRUD, create, read, update, and delete. They're the standard kind of actions that you get when you're talking about APIs and general data management within a database. But an action can also be more, less specifically tech-related. It could be an action to generate a report. Like technically that's creating data in a database, but report encapsulates a whole load of meta nuanced information. The action to create a report has on-flowing effects onto the underlying technical solution to that. But you might just want to create one action saying, is a person in this department allowed to create a report about some kind of object? Or are they allowed to approve something? Maybe it's approving expenses, or in my dream world, travel. Something like that. So different kind of actions can be attributes of this access control determination. And then, of course, we've got the object. There's no point in knowing that somebody can do something if we don't know what they can do it to. And objects can have different attributes as well. What type of object is it? Is it something like a medical record, which obviously you're going to want to keep much tighter controls around? Or is it a blog post, in which case pretty much everybody can read it, but who can edit and who can comment maybe? So there's different object types. Clearance level appears here again, because obviously if we've defined a clearance level for somebody, we know somebody has top-level clearance access. We need the object to also have a minimum level of clearance for that access to be granted. So you've got to double check here. The subject's clearance level has to be above the object's clearance level. And then geographic restrictions can be quite useful as well. Perhaps you work in a government organization and you're only allowed to access data when you're actually in the country, or maybe even in the building. And then contextual provides a way of determining more ethereal kind of things that aren't necessarily related to the physical, even though some of these are like virtual objects, but we've got these physical feeling kind of things like where am I, what kind of object is it, etc. But less specific are things like time and location. And location fits into the geographic restrictions as well. Obviously, we know that if we know a document can only be accessed from within Government House, then the location as a contextual bit of information into determining whether or not somebody has access is very important. Time as well. Maybe you can access it from anywhere in the world, but only between certain hours. It still reminds me of this time when probably about 15 years ago, somebody came up to me. I was working for a digital agency, and they said, so we've got this online shopping cart system, but we want to make sure that people can only buy between 9 and 5 because we're closed the rest of the time. I don't think that's an appropriate use of using time for giving or denying control to buy something, but that was just an interesting thing that just popped into my head. I'll continue. So time and location are contextual things that you can add in. So you can go through and select a whole lot of things to determine whether or not access is granted. So let's say, for example, we want to check whether somebody has approval is authorized to approve. That's the action. We know that their clearance level matches what they're trying to approve, and we know that they're within the location that they're supposed to be, either within the office, within the country, whatever it is. Or this could also be a virtual location. Are they connected via VPN? And if so, then we give them access. So that's obviously quite complex. There's a lot of moving parts in there, and you can imagine the management of that and oversight and making sure that changes are audited and all of those things. It's a fairly complex process. Role-based access control, which I had a great question about this once before. Is role-based access control just a subset of attribute-based access control? And in many ways, yes, because attributes are very generic things, and a user, a role, and a permission are all attributes of something. So yes, it is a subset of access-based access control. Attribute, I told you I'd mess it up, attribute-based access control. But role-based access control is a lot more linear. It's much easier to conceptualize in your head, therefore it makes it easier to manage, and you could argue also it makes it harder to get wrong, which will keep you more secure. So this is probably why you've noticed this a lot more. If you have looked at any kind of access control, you'll probably notice that role-based access control, which might not be termed that way. When we go through the description now, you might reflect on having seen this before, is more prevalent than attribute-based access control because it's easier for end users to manage and to configure. So in role-based access control, we essentially have three. They're not really columns like we had in the attribute-based access control, but there are three entities. We have the user, we have a role, and we have a permission. A user can have one or more roles, a role has one or more permissions, and conversely, permissions can belong to multiple roles, and roles can be applied to multiple users. And it makes it really easy to get from one end to the other. Does this person have permission to do that, or who has permission to do this action? So you can have Sarah, for example, who's a senior partner at a law firm, and we know that because she's a senior partner, has permission to terminate associates. I've been watching a lot of Suits recently. I just got to the point where Mike and Rachel moved to LA, and no spoilers, please, thanks. So this is really easy for us to understand. As end users managing a system, it's really easy for them to understand. So again, role-based access control, a lot more prevalent. So comparing those two, I've pretty much hit on most of these already. Attribute-based is really powerful. There are so many things you can control, there's so many things you can test for, but it does make it really complex. For the benefit of being fine-grained controlled, it makes it really hard to conceptualize. If you looked at a whole set of rules for attribute-based access control, it would be really hard in your head to work out who's got access to what and how do we audit to make sure that everything is as it's supposed to be. Whereas role-based access control is so much simpler. It's really fast for you as a brain, as a human with a brain to comprehend, but it's also really fast for a computer to determine the outcome of the test, should this request be authorized or not, based on what we know. Imagine creating like the logic tree of all of the attributes and testing each one of them to work out whether or not somebody has access to do something. And then imagine the simple test of saying, okay, well, does this person through these roles have access to do this? RBAC is so much easier. It's going to be less CPU intensive. It's more coarse-grained. You can make it more fine-grained control by having lots and lots of permissions and lots of roles, but that's not the point of RBAC. So for the advantage of being fast and simple to comprehend and easy to maintain and all of those things, you lose slightly because it's generally a more coarse-grained access control determination. I hope that makes sense. So the ultimate question, I'm sure you're all asking, which one should I use? Hands up, because I can actually do this one now. You normally can't do this when you're doing these talks virtually. Hands up if you think it's access-based, attribute-based access control. I've got one. I think you're just putting your hand up, or two. You're just putting your hand up because you're feeling sorry for me because nobody's engaging. Hands up if you think it's role-based access control. About 50 times as many. You're right. No, you're actually both wrong. The answer, as always, is it is both or it depends. Actually, I didn't give you that option. I should have asked you. That was option 3. Hands up who thinks it's both or it depends. Oh, come on, I've given you the answer. You should all have your hands up. Anyway, I'll continue. So my recommendation would be to start with role-based access control because it's simpler, it's faster to set up, it's faster for a computer to determine whether or not access should be granted, and it'll do most 80, 90% of what you need, maybe even 100% of what you need. And then if you get to that point where you think, you know what, I need slightly finer grained control, and the number of permissions and the number of roles I have in my RBAC setup is getting a little bit out of control now, then overlay that with attribute-based access control. That way you get the benefit of both worlds. You can very quickly determine whether or not there's an easy yes or no, and I said at the beginning that there's not really an it depends, but you could at this point have an it depends, at which point you then activate the attribute-based access control test to see whether the extra information and the slightly extra processing time that's required to do it will give you an outcome. All right, so all of that being said, I'm going to go into a demo. The thing that I want to demonstrate today is how you can define, and again, I'm going to be using JavaScript in the demo. If you are not a JavaScript Gatsby React developer, or you're not familiar with Node.js or any of those things, it really doesn't matter. The concept is what I'm trying to demonstrate here. But rather than spend, I don't know, 20 minutes setting up the demo from scratch, I've got a couple of slides that just shows the process that I went to get to the point at which the demo starts. So we're going to start with a Gatsby front end. So I've basically run Gatsby new front end. I've gone into that directory and using npm, I've added the Auth0 React library. So again, this is not Auth0 specific. If you use Keycloak, which is an off-the-shelf open source solution, or any of the other identity providers, they all support OAuth to OpenID Connect authentication. The authorization part is specific to Auth0, but again, each identity provider is going to probably have their equivalents. So we've got our Gatsby application set up. The next thing that I do is I go to the Auth0 dashboard, and in there I've created an application and an API, because we've got a front page, single page app, which is our React application, and our node-based API. We need to configure those in Auth0. I'm not going to go too much into the configuration to get it up to that point, because it's all part of these quick starts. So I've basically gone through the quick start for React, and I've gone through the quick start for the API, which is running Node.js. I'm not quite sure if you can see that there, but essentially we've got the code at the bottom there that I've copied and pasted and put into the applications already. And what that looks like is within React, we've got the concept of we've got the Gatsby browser JS file, which is basically where the root of the application first gets rendered. This is the pre-compilation step. So Gatsby pre-compiles into a React app that is then running in the browser. So during this step first, we're going to wrap it in the Auth0 provider. Don't really need to know what providers do, except to know that now every component inside this application has access to the domain, the client ID, the audience, the redirect URI, and the redirect callback method, which is what's required for any authentication OpenID Connect standards compliant identity provider to perform a login, basically. So all of our application, all of our components now have access to this, which means that when we come to define our admin page, which is the only one that we really want to secure, normally you would just define the admin page as a variable here, and you'd export default admin page. That's all you would normally do in React or Gatsby. We're just wrapping it with this function, which is provided by the Auth0 library called with authentication required, which now means that the user is going to be forced to be logged in if they're not already logged in. Those are the only changes I've made to the front-end application. And then the back-end application, we're not using any Auth0 specific libraries. We're using the standard JWT library for Express, which allows Express. So the way that I'll just do a quick overview of how the authentication happens. You log into Auth0, and then the front-end application is going to make a request for tokens based on the person who just logged in. And you'll get an identity token, which tells you about the person who logged in, an access token, which gives you information that you can then provide to a third party, like an API, to make requests, and it defines the access that you have. And we'll see an example of that one in the demo. But JWTs are standards compliant. So we're just using the standard Express JWT library to interpret and validate that the JSON Web Token is correct, valid, hasn't been modified by checking the signature. And the JWKS RSA module is essentially just a tool that allows us to grab the public key for verifying that signature. And again, this was copied and pasted out of the quick start, so really easy to get up and going. And then another document on the Auth0 website gave me this snippet of code, which basically allows us to define a method that we can pass a permission or a scope name into. Again, we'll look into this in the demo, and it'll return a true or false. Does this person have this permission? And then the final change is that for every endpoint that we connect to, in this case, post items, which would be for creating a new item in the database, we check permission to see that they have the create item permission. All right, with that said, due to the technical setup here, where I'm actually using a machine at the lectern in front of you, I can't actually share my screen and do an actual live coding demo, so I've pre-recorded this. But we will have time after this video to go through any questions you have, and if you do want me to do more of a demo or go into any of the code, then with the organizer's consent and blessing, if it works, I can still share my screen and we can try and do some stuff, but hopefully this demo contains all the information that's needed. I am speaking in the demo, so I will be quiet now and let you listen to it, but we can revisit any of this. Let's just hope this goes well. And if you can't hear anything, I'm sure somebody will tell me. So, cross fingers. Hope this works. Good luck, everyone. I'll see you on the other side. Okay, so let's take a look at this demo. We've got a sample shopping cart site, and you can buy a burger, pizza, or tea. What we want to do is be able to log in and make changes and additions to this menu. So the first thing we're going to do is log in, and we'll provide the credentials for the account that I already have. And we can see now that the admin menu has become available. If I click on that, we can come through and we can see here that we can edit an item, save changes, but we don't have permission yet. We can delete an item, again, we don't have permission for that. Or down at the bottom here, we can click on add, create the item, again, we don't have permission. So let's have a look to see what we can do in terms of enabling role-based access control within Auth0. So we already have the Auth0 SDK within React and within the Express API configured to use the, if you're not familiar with the Auth0 dashboard, we have a list of the APIs and the applications over here, and they're already configured to use these. So we don't need to do any of the integration. We've seen already how the steps that we went through in order to create the React application and also the Express API and how we integrated the SDKs in there. But what we do want to do is create some scopes or some permissions that we can apply to the API so that when the front end calls the API is then able to determine from the access token whether or not the currently logged in user has permission to do the actions that they're trying to perform. So let's jump into the API over here. We'll see the ye olde API is configured here. There's the Auth0 management API, which will come predefined in every tenant that you create. It's basically a way for you to connect to Auth0 in order to control everything that goes on in the dashboard here programmatically. So we want to have a look at the ye olde API, which we've created for our application set. And if we jump over, we can see here there's the permissions tab, and we want to add some permissions that our users are going to be able to take. So the permissions that we want are create items, and we can give it any kind of description. For simplicity purposes, I'm just going to copy and paste the same item in. So we want a permission for creating items, we want a permission for updating items, and we want a permission for deleting items, delete items. So these have already been configured in the API source code. So when certain endpoints are called, if you're trying to create something, it's going to make sure that the current user has that create items permission defined down here. Next step we want to do, before we go over and start creating our roles, which is under the user management area here, before that we need to jump back into the settings tab for the API, because one of the things we need to activate is the role-based access control measures. And if we scroll a little further down, you'll see here that we can enable role-based access control. So I'm going to click on that just to enable that. And we also want to select to add permission to the access token. So at the moment, you can enable role-based access control, which will be able to take the roles into account. But we also want the access token to receive the permissions so that our API can look at those permissions in order to determine what actions can and cannot be taken. So I'm going to come in and just enable that one there as well. Come down and hit save. Now the next step we want to do is have a look at roles. So let's create a first role, and we're going to create one called admin. And the admin user is going to be able to have all permissions. So if we come into permissions, we can add permissions. Now, because there can be multiple APIs defined within your Auth0 dashboard, you have to select which API you want to give the admin role permission to first. And once we've done that, we can see the permissions that have been defined in there. And the admin can obviously do all three of these. So we'll add those permissions. Let's come back to roles, and we're just going to create a new role called editor. So the editor is able to go in and change things and add new items, but we don't want to allow them to delete things. So we'll come in, we'll select the API again, and we'll say they can create, they can update, but we're not going to allow them to delete items. So we'll add these permissions here. And if we go back to roles now, we'll be able to see that the admin and the editor role are in there. So the next thing I need to do is go in and define which roles my user has access to. So you can come in through the ... thing over here and assign roles. You can also edit the user itself and see the roles tab at the top over here. You can also define permissions directly. I would personally recommend against this. It's better to assign permissions to a role and then assign a role to a user. That way, if you want a particular role to have new permissions, you've only got to change it in one place and all the applicable users get that benefit. There might be edge cases where it's useful to give one particular user a certain permission, and in that case, sure, go ahead and use the permission system, but always have a consideration, have a thought about whether or not you can define it within the role itself. So we'll come in and we'll assign a new role to my account, and to start with, I'm going to select the editor role. So we'll assign that, and we can now see that the editor role has been assigned. If we jump back into the permissions tab here, we can actually see the permissions that I've inherited through that role assignment, and you can see here that it's because of the role assignment. Can't actually delete them from here. You'd have to modify the role, but it shows you that you can assign individual permissions, and also you'll get an overall view of what permissions a particular user has, including what they inherit through those roles. So that's a nice little representation here. So I'm just going to log out over here, and we're going to log back in order to get a new access token. But before we do that, I'm just going to jump over so that we can have a look at what the access token looks like. And we'll grab that out of the network tab once we get to it. So I'll hit login. We're taken to the Auth0 login page. And we'll log in. Now we can see we're redirected back. If I just filter the URL up here, the way that the login process works is the single page app that we've got, the React app here, is going to make a request to Auth0 to retrieve the tokens. And the endpoint there is called token. The full URL is OAuth/token. So we can see here that we made an options request, which is basically a way for us to ask from the API what capabilities we have on this endpoint, and then the actual post request, which is basically sending some authorization code in order to say, hey, I want to retrieve information about the current person who just logged in. And if we look in here, we pull this up, and we have a look at the response, we'll see an access token and an ID token. And I'm just going to copy the access token. We'll head over to jwt.io, which is a nifty little tool for looking at JSON Web Tokens that a colleague of mine wrote. And I'm just going to paste that in here, and we can see here's the payload. So if you're not familiar with what a JSON Web Token is, essentially we've got a header, a payload, and a signature. At the moment, we just want to have a look at the payload to see what's going on, what kind of information is being sent to the API for every request that I make, because this JSON Web Token is going to be sent in the header of the requests from the single page app, from the React application to the API. And no matter what front-end application you're using and what API platform you're using, that's the way that a JSON Web Token will be sent through the authorization header as a bearer token. And we can see in here that we've got the permissions array, and the API is going to be able to determine that the currently logged in user has permission to create and to update items. So we jump back over into our application here and head over to the admin tab. We know that we can come in and edit, so I should be able to pluralize this to burgers. We can see down here that it's currently still singular. And when we hit submit, it says burgers plural. And if we look back at the home page, the title here is updated as well. We can also come in and add a product. So we could sell maybe Smarties. This is not an endorsement or an advert. It's quite cheap, just $1, Yum Sweets. And I'm not going to find an image right now, but we could define an image in there. I can create this item, and now we can see that we've got our Smarties. We've got the sample product image, and also it's showing up on the homepage. But of course, we don't actually sell Smarties, so I better delete that again. But as an editor, I don't have permission to do this. So we can see now that the power of role-based access control and the permissions assigned to me as an editor mean that I'm locked into only doing those activities that I should be allowed to do. If we jump back into the user here and let's look at the roles, and we'll assign another role, we'll assign the admin role. Now I could also delete the editor role at this point. The permissions are going to be cumulative, and you can see that I've now got permission to delete. If I deleted the editor role, I would still have, let's do that, let's delete the editor role. I would still have permission, if we jump back in here, for create and for update, because they're also part of the admin role. But you can have multiples with overlapping permissions, and that's all going to work fine. So let's jump back in over here, and we'll hit log out, and we're going to hit log in again. Helps if I type the correct password in. And now if we look at the new token that we've received, let's just copy this and paste that back into here. Before we had create and update. Now when I paste the new one in, we can see we've got create, delete, and update. So with this new token now, this token is being passed into the API for verifying who's making the request and also what permissions they have. I should be able to come into admin now, hit delete here, product's deleted, back to the home page, product's gone. So that's obviously, there was a bit of code that we saw previously that would need to be put in order to verify the ID token, but also have a look at the access token, look at the permissions, the authorizations that are inferred through that, and each of the endpoint functions is then protected by a check to make sure that the permission required for that particular call, that particular request, is actually granted. So the create permission has to be there in order for somebody to be able to add something, and if not, then the API is going to return a 403 unauthorized. Otherwise it's going to go ahead and return whatever results is expected, probably a 200 OK or a 201 created, and the front-end application can then handle those in whichever way is best for that to be reported back to the user. In our case, it was just an alert box. Make it prettier and friendlier if you like. I should probably modify that video embed to not then recommend a whole load of extra videos at the end. Well, I hope that demo was sufficient to help you understand how the role-based access control works. One thing that I really like about and again, it's not Auth0 specific, I'm sure there are other identity providers out there that do the same, but being able to encapsulate all of the roles and all of the permissions into the identity provider, and then having the JSON Web Token with the signature, which allows us to trust the JSON Web Token's payload, the API then has a lot less to do. It doesn't need to look at the access token, find the user's identity, look up in a database somewhere to see what the access control list definitions are there, determine itself whether or not it can or cannot do something. It's all wrapped up in the identity provider, and there's a simple flag in the access token that the API or whatever end system is consuming that API, consuming the JSON Web Token, it can trust. So I know I also skirted over a number of things in the demo, like what a JSON Web Token is, how they're created. I'm happy to take any questions on that as well if you want more of an overlook on how JSON Web Tokens, OpenID Connect, OAuth 2.0 work in this context. But also if you have any questions around role-based access control, attribute-based access control, or anything else you've seen, I'm more than happy to take them now. I think there's a mechanism as well for anybody who's online to send questions through. But while we wait for any of those, and just before I hand over to you, I just wanted to give you a couple of links. So if you want to play with the code that I demonstrated, the front end and the API are both at the GitHub URL here, the old eShoppy, and the entire presentation that you've just seen, including the embedded video, is available at this URL here. We are giving away t-shirts as well. I always like to give away t-shirts. Most people love them. If you are interested in an Auth0 t-shirt at all, a0.2/feedback Ben will just ask you to tell us about how you thought this talk went. And in return, everybody who submits a bit of feedback will get a t-shirt sent to them. So with all of that, I'd love to thank you for your time. We do have still about 15-20 minutes before the end, so we've got plenty of time to go through in Q&A if you want. Otherwise, you'll have a bit of a break before the next talk. Thank you.
Thank you, Ben, especially for doing it remotely. I have a question from an online user. Why does the app need to have both an SPA client and a regular web application client registered in the identity provider? Is the latter actually the API or server app?
So in this particular case, and there are many different ways that this is more of an OAuth OpenID Connect question rather than the access control itself, which is fine. I just wanted to kind of frame that for everybody else. There are 4 types of, when you create an application in Auth0, in fact, actually, no, I'm not logged in on the laptop over there on the other side of the world from me. Otherwise, I'd log in and I'd show you the dashboard itself. But when you create a new application, you get the choice between a regular application, which could be like a Python or a PHP server-based application that serves HTML. It could be a native application, which is your Android apps, your iOS apps, desktop applications, and then you've got single-page apps which run completely in the browser. The 4th type is machine-to-machine, so if you've got 2 computers that need to talk to each other, that's another way, another form of using OAuth to authenticate them. So we need to define within the identity provider, Auth0, or whichever provider it is you're using, you need to define each of these applications, because that application is going to get its own client ID. It's going to have a client secret. Obviously, we can't use the client secret in a single-page app scenario because it's all in the browser. But if you're running a native app or a server-based traditional backend application, you can obviously put in your secrets into the code there. So that's why we define the application. The API itself, the definition in Auth0 for the API doesn't really have any bearing on the API itself in terms of the way you code the API. There are a couple of things you need to add into your API for being able to retrieve the public key, for verifying the JSON Web Token. The main reason we define an API within the context of the Auth0 dashboard is so that we can do things like attributing permissions to APIs themselves. Within a single-page application, when you get your access token back, that access token doesn't need to be linked to an API. But, for example, if you're writing a Python server-based application and it needed to talk to another API written in whatever other language, same language, different language, doesn't really matter. In order for a token generated by the identity provider to be usable by both the backend application and the API, you need to link those together in Auth0, and that's just to ensure that tokens can't be consumed by systems that they're not intended for. So there's various reasons why we define those in the Auth0 dashboard, which are mostly around configuration and security. The implication with the API part is not so much for the implementation of the API, but more for the configuration of how it sits within the whole identity ecosystem. I don't know if that last bit made sense. I started trailing off a bit, but does that make sense? I hope so.
Thank you, Ben. Are there more questions here from people here? Okay. Can you? You speak very loudly for your question. Or Austin, do you want to?
I recently implemented Auth0 with an identity provider, and we use in a certain way. If we use by an API. The question is, where do you save? What's the safest way? What's the safest way to save the JWT tokens within an application or within a client application? If someone can steal that token, can they access, in my test, I was able to access a couple of APIs, though I was on a different application and using the same token. What's the safest way to save those tokens, the OAuth tokens? And part 2 of my question is,
is there a way when the endpoints of an API are being accessed but with a token to verify again in signature that it's coming from the right client, irrespective of having a client ID, client secret, or in case of client credentials or password protected, still the token can be used to access those APIs, even if it's higher level of security. What's the best way to save the token in the client app? And number two, is there a way to second check the endpoints when those tokens are used?
They're two very good questions, and one that'll take a little time to explain, to go through, and I'll take it slowly because there's a lot going on in my head right now. Also, I missed the start, so I'm not sure whether you're particularly talking about single-page apps or server-based apps, but I'll cover all of the scenarios anyway. So, in the case of a single-page app like the React application we were looking at, everything is in the browser. So there's a much higher security risk there because you could have a malicious browser plugin or a cross-site scripting attack or any of these kind of mechanisms that could somehow access the information that your web application has access to. If you've got two tabs open across different domains, then a cross-site scripting attack could inject JavaScript into your application somehow and read information from the variables, which is where your tokens are going to be stored. So that's the most dangerous scenario that we really consider. In that sense, there are three places where you can store the access tokens and the identity tokens, and that would be in memory, so just a local variable within your application. You could store it in local storage, or you can store it in a cookie. The latter two are highly not recommended in most senses, because any application can potentially get access to that information, whereas in memory it's going to be harder. It's still not impossible, but the complexity of trying to dump all the variables out of memory in a running application in a browser through a cross-site scripting attack is quite tricky. Less tricky, but still hard, is to do that via a malicious browser plugin. They could try and have a look at everything in memory and see whether anything in there looks like a token and siphon that out somehow. But again, it's a complex task, more complex than just scanning through local storage or your cookies. So that's the single page in-browser running scenario. I'll loop back, and if I forget, tell me to loop back to tell you about how we manage remembering people between sessions in that scenario. Backends, if you're writing an application in Python and it serves the HTML, or you're writing in PHP or .NET or whatever language you like, in that situation, your memory, your application's memory storage is on a server. It's a lot more secure. It's in an environment that ideally, hopefully you trust. It's not a browser. So in that case, you can store it in memory. You can store it in local session variables, which can be linked to the cookie, and you can send a cookie to the browser. In this case, make sure there's an HTTP-only cookie, so that JavaScript can't read it and extract it. That HTTP-only cookie will be sent with every request back from the browser to your server. Server can reinstantiate the session, and the session can contain the access tokens. So that's where you would store them, basically like you would store any other kind of private-ish information about a user who's currently logged in, where you have a session-based connection with a browser. Those are the primary. So a native app, similar kind of thing to a server-based application, because it's wrapped up in an application running on a phone or on a desktop that's in an environment you trust. So again, store it locally. If you want to persist that in a local environment on an iOS or an Android app, then make use of the built-in phone APIs for secure storage, for encrypted storage. You can put it in there, and then theoretically only your application can get those out of that encrypted storage again. So that's where you can keep it so that when you close the app and you open back up again, it'll be able to reinstantiate the user without having to log them in again. So revisiting now the single page app scenario, where you've stored the token in a local variable, which then means that if one of your users right-clicks and opens in a new tab, or they close the browser and then they come back again, the locally stored variable contents, being the access and the identity token, will obviously be gone, because the application's been respawned in a new application, therefore the memory is brand new, or whatever. I think you get what I mean. So in that situation, there is a transparent reauthentication mechanism that most identity providers support, which essentially under the hood is a web worker going off to the identity provider's an endpoint. It's not actually the login page, but it's kind of a checkpoint that just says, hey, do you currently have a session with this browser? Because again, Auth0 and the identity provider is a server-based application, so they can have a secure HTTP-only cookie and a session with the tokens there. And then your application from the front end can just say, is this person logged in? And the identity server can return new tokens, which allows the application to, it's not really state, but it can reinstate the identity of the currently logged in user based on the session they have with Auth0, as opposed to your application. And then you just, that's why it's called transparent, because the user's unaware of any of this taking place. If Auth0 comes back and says, no, we don't have any tokens for them, then your application can choose to force the user to log in again. But you get that effect then where you can right-click, open a new tab, and the user isn't logged out, which was a pain a few years ago. So I think that addresses the where to store it. You also asked about, can we invalidate them? And yes, there's no way, and you're absolutely right. You tested before, you had a JSON Web Token, and from a different system, or even you can open Postman or use curl on the command line, and you can paste it in as a header. You can make a request to an API, and it's going to say, thanks to the API token, that's exactly what I wanted, go ahead. Because the API token is essentially a key. Anybody with a key can get into your house. So the risk there is similar to somebody losing a cookie. If you were logged into an application and I managed to get your cookie somehow, then I could also put that back into my browser or use a curl request and reinstantiate your session with that server. The server's not necessarily going to check that it's from the right place. Now, you could do things like checking IP addresses, which you could do both in the cookie scenario and the API, the authentication access token. Brain's going off on tangents, the access token scenario. If the IP address changes, then you can either log them out or you can do some kind of escalation procedure, like we noticed you're coming from somewhere else, we're going to have to get you to re-authenticate. Various things you can do at that point. The other thing you can do, and you alluded to it, is a blacklist. So with access tokens, you can't invalidate an access token from the identity provider. Whereas with the traditional access tokens, the non-JSON web token type access token, which are the or opaque tokens, which are the long 64-ish character gibberish cryptographically generated randomly whatever strings, those can be invalidated because your API needs to go to the identity provider and say, hey, is this token valid every time, which is something you don't have to do with JSON web tokens at the cost of not being able to invalidate them from a central point. What you can do, though, if you, and it is not every scenario is going to face this situation, if you find that you need to be able to invalidate tokens, you can run a blacklist service yourself, which is very simple. It could just be a mem cache somewhere where you store all the tokens you want to invalidate. And your API can just say, is this token in the blacklist? Yes, drop the connection. The advantage of that is you don't need a huge amount of storage because you only need to remember the tokens until they expire, and then they're invalid anyway. So that's a really simple way of implementing a blacklist for access tokens. I hope that answers that question too. I'm getting nods, so that's good. Thank you.
We have a few more questions online. Do we have questions from people here? Right. For people who have posted their questions online, I would request you to reach out to Ben on Twitter or on any of these platforms, because that's all the time we had. Unfortunately, we'll have to move on to the next speaker. Thank you for presenting, Ben.
You're welcome. Thank you for taking up so much, sorry, rather, not thank you. Sorry for taking up so much time on that last question, but I thought it was a really important one. So I hope that was valuable to a lot of people.
Thank you.